My name is Don Hilborn, and I'm a principal engineer with Hortonworks Global Alliances organization. Today, I will be discussing the distinct value proposition that Hortonworks offers our partners when implementing a single-view solution. First, we will review the problem our customer was facing. Next, we will look at the solution they designed. After reviewing the solution, we will drill into the architecture and sizing best practices, which will lead us into the customer's implementation plan. And finally, we will wrap up with the overall project cost and ROI. First, let's review the problem that Megacorp was facing. Megacorp has consistently seen a loss in market share on the Genie game stations, in spite of the fact that the overall market for Genie is growing. Although it appears not all stores have lost market share equally, Megacorp as a whole has lost 50% of their market share for the Genie game systems over the past 4 years. This loss has cost Megacorp $400 million in revenue annually. Profit margins are very tight on these game stations, so $400 million in revenue translates into about $8 million in profits. As you might imagine, Megacorp is very interested in getting a handle on the situation by getting a single view of everything going on with this product. Ms. Brady knows in order to understand the cause of the market loss, she needs to get a view of the product and individual stores from all angles. Ms. Brady tasked her business analyst, Tam, with gathering the necessary data to get a handle on how Megacorp's customers are shopping for the product, how many of the products are being purchased and returned to what stores, as well as what's being said on social media about individual stores and products. Tam considers 4 questions she must answer to better understand and mitigate the market loss. They are, is there more negative sentiment about certain stores, and does that correlate to lower Genie sales? What percentage of Genies are being returned and why? What is being said on social media about the products and stores? Initially, Tam's team is concerned that they may not be able to capture all the necessary data to answer Tam's questions in order to help her increase market share. They know that the data is not all structured, and some of it is created in real time and transmitted over the internet. In addition, some of the data will have to be captured from external sources. The team recognizes that their current data architecture limits their ability to gather and process the data needed because of data silos, their limitations on economically gathering all the data, as well as some of the new data sources. The Hortonworks data platform fills these gaps and complements the existing architecture with numerous integration points. The team attends Hortonworks training at Hortonworks University, which augments their existing skills and gives them the skills necessary to architect, develop, and implement the modern data architecture. Now let's discuss the solution Megacorp implemented. Tam and Varun build an app with the help of their favorite SI that gathers information from all the various sources, integrates it, and presents it in an actionable dashboard. The system uses HDF and Scoop to gather data, and HDP to integrate and capture the data, and finally Zeppelin to visualize and analyze the data. Ms. Brady is happy with the results. With data from the ERP and POS system, she is able to determine what subset of stores are responsible for the loss in market share. Looking at data from the POS system, social media, and CRM systems, she is able to determine the loss of market share correlates with poor product placement, lack of training of sales associates, and cluttered stores. But like most managers, she's not happy for long. Now Ms. Brady wants to be able to predict which stores in the future are at risk for market loss. Jeff points out that HDP has tremendous machine learning capabilities, and he can monitor the systems in real time and use the correlated conditions identified earlier to predict which stores are likely to have an event happen before the event actually occurs. With the help of their favorite SI, Jeff implements a predictive model leveraging Spark that alerts Miss Brady when the conditions are present that predict the loss of market share. Now let's look at how Megacorp, with the help of their favorite SI, built out and properly sized a reference architecture. The team put together a detailed architecture of the proposed solution using HTP and HDF. The architecture sources data from numerous sources, including legacy data, clickstream, log data, social media, and unstructured data. This data is easily accepted into the flexible schema of HTP, using HDF and Scoop to load the data in. The data is processed using Hive and indexed using Solr. Then the data is made available in a real-time dashboard as well as visualized for reporting. The team uses Hortonworks Storage Calculator to determine the storage requirements necessary to store the data along with the required history in HTP. The team ingests the structured data into HTP using the bulk loading technology Scoop. That is part of the overall HTP stack. Above is an example of the Scoop connection information that loads the data in bulk to the highly performant and compressed format of ORC. The team uses NiFi to ingest numerous sources in real time as well, which is also part of the HTTP stack. Above is an example, NiFi Flow, that loads the data in real time. When it comes to processing data, the Hortonworks Data Platform is an open enterprise Hadoop platform built on a centralized Yarn-based architecture. It supports multiple processing engines running in Hadoop, including a number of SQL engine implementations. Today we'll focus on two. The first is Apache Hive, is the most widely used SQL engine on Hadoop. It provides standard SQL interface to the data stored in Hadoop. Users can leverage their favorite BI tool to quickly find value and raw data files. And Hive is proven at the petabyte scale for batch query execution. Open Enterprise Hadoop leveraging the Hortonworks Data Platform is all about choice, and this is particularly true with SQL engines on Hadoop. The Apache Spark project has provided a fast, in-memory data processing engine to the community. Spark provides elegant and expressive development APIs. It allows data workers to efficiently execute streaming, machine learning, or SQL workloads that require fast, iterative access to data sets. Apache Spark has been certified and runs on Yarn, which enables data scientists to run multiple workloads within a single shared data set in Hadoop. Megacorp needed to consider the strengths and cautions associated with both Apache Hive and Spark SQL. These are some of the strengths and cautions that they considered as part of this project. When considering which SQL engine to use for Phase 1, Megacorp needed to keep in mind the unique capabilities of Hive and Spark. Hive has a robust, cost-based optimizer and mature ecosystem and is an excellent choice for ETL offloading, reporting, and large-scale aggregations. Spark SQL has a language-integrated query capability which supports exploratory analytics and dashboarding. Both tools have been evolving rapidly, and we anticipate each will continue to offer more and more value to the market as new releases are delivered. Apache Zeppelin is a web-based notebook that enables interactive data analytics. It works well with both Hive SQL as well as Spark SQL, among others. HDP also supports tiered storage. This allows for storing more active data that requires quicker responses and faster storage while maintaining other data in more economical mediums. The team used Hortonworks' sizing equation to determine the storage capacity they needed. Higher replication counts impacts query performance and data availability. It is hard to accurately predict the size of intermediate and materialized views at the start of a project, but this equation will get you started. Be conservative with compression ratio, keeping in mind that HDP needs temp space to store intermediate files. The team used Hortonworks' recommended performance configuration for the data nodes, which allows for 14 terabytes of raw storage per node. Given the compression algorithm and the replication factor, this means that Megacorp required 11 slave or data nodes. The team uses Hortonworks best practices sizing for Solr to determine the processing requirements necessary to index all of the data and make it searchable and discoverable. A detailed look at the Solr sizing helps us determine what we need. 65 gigabytes of RAM to index and maintain this content. This should allow a single performant node to support Solr. The Megacorp team used Hortonworks best practices sizing for NiFi as well to determine what was necessary to have NiFi ingest all of this data. It looks like a single performant node should support NiFi as well, perhaps 2 nodes in order to ensure redundancy. Gives the overall sizing for the processing nodes necessary to support Megacorp's cluster. These are our specs for the name nodes, in this case 2 name nodes with 12 cores, anywhere from 128 to 256 gig of RAM, a small SSD drive for the operating system, some SATA drives for swapping space and other storage, as well as a 10 gigabit switch. For edge nodes, we use the master node class for NiFi, and this is the configuration of that. These servers cost approximately $5,000 to $8,000 per node. The Solr node specs, we're looking at 12 cores, 64 gig of RAM. Again, the SSD drive for the operating system. We had some extra SSD drives for swapping to improve performance, and then a 10 gigabit switch. The slave nodes are a little bit smaller with a little bit less RAM. And then, of course, there's much more storage at the SATA level used for performance servers. We show here a server configured for processing optimization with the maximum IOPS, as well as a balanced server, and then ultimately a storage optimized server, which would allow you to store a lot more data if you weren't going to be doing a lot of processing on that data. This is Megacorp's service distribution, showing how the services lay out over the different nodes and where those services would actually be deployed. Generally, we recommend deploying all services, but you notice here in some instances those services may be suspended, so they don't actually affect the cluster. They're simply there and available when you're ready to use them. Now let's look at the project and resource plan Megacorp put together with the help of their favorite SI to implement this solution. Cam, the business analyst, put together a quick project plan and estimated that it would take about 90 days to get Miss Brady her solution. The plan included a strategy session, building out the cluster and the solution, as well as socializing and communicating the solution internally to other organizations. The resource plan teamed Megacorp resources with their favorite SI resources to ensure proper knowledge transfer and transition when the project was complete. Finally, let's look at how much this all cost Megacorp and what their return on investment was. Project costs are broken down into hardware, software, consulting, training, and overall travel expenses. Looking at 16 nodes total, at an average unit cost of $10,000 per node, hardware cost came out to approximately $160K. Software cost, approximately $120K. Consulting at 2,800 hours, an average hourly rate of $300 an hour, was $840K. And then training for 20 associates came out to around $50K. total travel and expenses at about $100K, making the total project cost $1.3 million. Megacorp was able to regain their market share after making these changes, resulting in a total increase in income of approximately $8 million. Given the project costs, this meant that Megacorp's ROI in this project was roughly $6.7 million. Thank you. I hope you found this productive. Please visit HortonWorks.com to learn more of the value proposition of HDP and HDF.